Good morning, all of you. Today we are going to study chemical kinetics lesson from which first order application. First, we should know the what is the first order and what are the formulas. Order of the reaction is the sum of the powers of the concentration of the reactants raised to the power in the rate law expression is called simply first order. So first order expression equation based on the statement we can write the expression r is equal to k into concentration at. K is the constant of first order, r is the rate of the reaction first order, at is the concentration of the reactant at a particular time. We may write another way, r is equal to k into a minus x power of 1. 1 indicate that first order. Sum of the powers of the concentration always equal to be the 1. We may other way could be write r is equal to dx by dt. X is some degree of dissociation of the reactant is equal to k into a minus x. A minus x or at both are the same. At is equal to we may write a minus x. Okay. And if you could be integration this expression we get after k is equal to 2.303 by t log a by a minus x. A is initial concentration, a minus x will be the final at a particular time. Suppose we say expression chemical equation a gives rise to products at t is equal to 0 concentration a after time a minus x. Initially p0, after some time it will be the x. Actually this is a generalized chemical expression. Now today we have to study one excellent numerical problem. After this question we have to realize very much. See, question is what N2O5 decomposes to NO2 and O2 and follow first order kinetics. After 50 minutes, the pressure inside the vessel increases from 50 to 87.5 mmHg. The pressure of the gaseous mixture after 100 minutes at constant temperature will be. So, from this question, what is given, what we have to do. So, while discussing this question, we have to first to make out the expression, chemical equation 2N2O5. Here, see decomposition to NO2O2. NO2O2 are the products, N2O5 is the reactant. Okay, see here 2N2O5 gives rise to 4NO2 plus O2. At initially at a zero time or initially no product will be formed. Just we have to take the concentration of the reactants in the form of the pressure. Here given pressure in the form of the pressure. At t is equal to 0, pressure will be the 50. After 50 minutes, the pressure will be increases to how much? 87.5. Pressure increased from to 87.5. So, we have to write here 50 minus 2p. Why should write here 2p? Number of reactants, how many initially? That is many number of times as we have to write here 2. So 2 times p. 2 times p decreases at the time 50 minutes. At the same time 4 moles of NO2 formed, 1 mole of O2. So 4 times pressure will be formed, 1 mole of 1 pressure will be formed here. 4 moles of pressure here, 1 mole of pressure here. So initial pressure of the reactant is 50. Mixture of the gases at 50 minutes will be the 50 plus 3p. Means what? 550 minus 2p plus 4p plus p. 4p plus p 5p, 5p minus 2p, that will be 3p. So 50 plus 3p will be the mixture of the gases at 50 minutes total. Entire vessel, it is a closed vessel. So because of is going on, we are going to get the pressures in pressures. Because of we have to always store the pressure in the closed vessel. That is why total pressure, mixture of the total pressure will be total how much it is 50 plus 3p. Pressure left at 50 minutes, pressure left at 50 minutes, what is the pressure of the N2O5? N2O5 how much left after 50 minutes? That will be the 50 minus 2p. See here at t 50 minutes, 50 minus 2p, that will be something. If you have to remove something left over here, that will be the 50 minus 2p. Okay, according to data, at 50 minutes pressure increased to the 87.5. Yes, 87.5. Now just to equate them, here the we have to find the gases mixture pressure at 100 minutes. Okay, 87.5 at 50 minutes increased. And one more thing, extra they are asking at 100 minutes what is the reaction mixture, what is the gases mixture. Okay, see, if you equate them at a reaction mixture total, that will be the 87.5. Okay, that will be, you get P is equal to 12.5. That is the degree of dissociation pressure. Initially 50 pressure is there, 50 mm of Hg is there. After 50 minutes something degree of dissociation takes place. Degree of dissociation is means what? The number of moles of the reactants reacted to the total number of moles taken initially. Here number of moles of the products formed to the total number of moles taken initially, that will be the degree of the pressure. Okay, at 50 minutes pressure of the N2O5 25 mm of Hg. How can you get if you get the P, just P substituted in the where 50 minus 2p. Yes, if you know P value 12.5, we want to find out the N2O5 pressure at 50 minutes, just substituted at the 50 minus 2p, then we get the value 25. Same like pressure substituted here 4p, then we get the pressure of the NO2. Likewise pressure of the O2, just I wrote here N2O5 25, NO2 50, O2 is the 12.5. Okay, this is at 50 minutes the pressure of the reactants and the pressures, reactants and products. Okay, now their question asking finally at 100 minutes what will be the reaction mixture. So whenever asked like that, we have to equate the at 50 minutes what is the conditions, at 100 minutes what should I have to find here. See here 12, actually we know that formula K is equal to 2.303 by T log A upon A minus X. So you take like that. See here both the side, every first order kinetics never depends on the constant value. So that is why K will be the always equal. So whatever the time increase or decrease, constant will be the same. That's why for both equation at 50 minutes we have to write the K is equal integration equation, first order integration equation. Here also at 100 minutes first order integration equation. Both of them we have equal them. Then if you see every value I entered here, but only we don't know A minus X. So just if you calculation, after all you get the A minus X will be the 12.5. See, this 12.5 become equal to the 50 minus 2p. Yes, see here this 50 minus 2p is what to this at particular temperature, sorry, at a particular time 50 minus 2p is the A minus X. I told initially this A minus X is what to 80 at a particular time, that will be the reactant left over A minus X. Here also same thing happen, A minus X will be the 50 minus 2p. So if you find here P, you have to get the 18.75. 18.75. This is also degree of dissociation at 100 minutes. Above we have to find the pressure 12.5, that is what at which time 50 minutes time. Now here we find out this pressure at 100 minutes. Okay, so here question asking that what 100 minutes, at 100 minutes what will be the pressure mixture, total gases present in the container, what will be the pressure. So just we have to do now 50 minus 2p plus 4p plus p, because of this total will be the reaction pressure. This total will be the reaction pressure, 50 minus 2p, 4p and p. So all this just added we will get, that is will be equal to how much. If you see the 50 plus 3p, See, we find out here p value 18.75, just enter here. Now we get, after all, you get the 106.25. Eventually we find out the answer. If you 106.25 mm of Hg, according to asking the question, at 100 minutes what will be the reaction pressure? That will be the 106.25 mm of Hg. It is a very good question, first order application question based on the pressure concept. Application on pressure concept. Thank you all.